Let's look at an example now that comes from programming. So this would be a snippet of C code. And so I have this. If age is greater than 10, then I'm going to enter the body of the if statement where I ask another question. If age is greater than 10 and weight is less than 200, then we would do something. That part doesn't really matter. And then close this up. Okay? So how can I use what we know so far about logic to analyze this and see, is there any way to tighten up this code? That's my point. We want to, is this the way it has to be written, or could we make it simpler? So let's let A equal age greater than 10, and B will be equal to weight less than 200. So what expression represents this? Well, let's think about what happens. In order to get to do something, age has to be greater than 10. If age is not greater than 10, then we never enter the body of the if statement. So age has to be greater than 10 to come down here and ask the follow-up question. And then in order to do something, age has to be greater than 10 and the weight has to be less than 200. So what we have here is this. We really have A and B, right? So I could have rewritten this as this way, and this will make the answer more obvious. If I want to, I could have written if age greater than 10 and age greater than 10 and weight less than 200, do something. That's not really simpler. That's not what we're trying to achieve. We're trying to see is this the way it has to be. Now we have this right here, but I have A and B, so I can use the associative property to rewrite this as, so those are equivalent, as A and B. So what's A and A? Let's have a truth table. And we really don't use truth tables for this, really. When A is true, then I have true and true, which is true. When A is false, I have false and false, which is false. Which means this right here can be replaced by just A. Okay? And that's what the simplification is. When I have A and B, it's really just A and B. So really I should just do this. Either if age is greater than 10 and weight less than 200, we'll say do something. Or, if you prefer, like I said, if age greater than 10, then ask the follow-up question, if weight less than 200, do something. Okay. They may look at that and say, wow, that's pretty simple. Let's do one that's not as obvious. Also C code. If not x is greater than 5 or is prime, say variable A, or, and we'll come down to the next line and write it, not x is greater than 5 and not is prime. So parentheses, this matches this, and then one more to match the beginning, and then do something. So we're assuming here this is prime function returns a value that would be considered true or false. So in C, 0 is false, any other number is true. Okay, so typically somebody would return 0 or 1 would be what would be common. Let A equal x greater than 5. B equal is prime of A. And so what do we have here? We see I have A or B negated. A or B not, or not A and not B. Okay. So we saw De Morgan's laws. And they said this. They said that A or B negated was equivalent to not A and not B, and that A and B negated is equivalent to not A or not B. Okay? So look at this. Let's change this one. So what is this right here? We'll put in 2 parentheses here. So A, we have this right here. So it's going to be an or in here. B, not, right? So the overall expression becomes A or B negated, or A, sorry, that's not there. A or B negated. Okay, so what's the truth value of this? So this right here, these two are the same, right? A or B negated with an or between them. So if I have A, and we look at A or A, true or true is true, false or false is false. So these are really redundant, so we can replace both of these with simply just a single one of these. Okay? So we could either do this, or I could have changed this to the other one where I negated each of these. It's up to you. Okay? But that's a simplification. Really, all I need to do is pick either this or this. These are really redundant. I don't need the or. So we might do this, for example, which is what this represents. So these parentheses go together, these go together, these go over here to do something. Okay? And if you want to, you could go through and take this right here and create a truth table representing the whole thing and see that it still just works out to this. So there's some simple examples. Now you may look at these and say, well, nobody really does this. Well, I can tell you from having taught programming classes for many years, I would occasionally see things that students would do that really didn't make sense. Maybe not necessarily this, but I might see something like this. I'd see, if x is greater than 5, A equals 10, B equals 6, else B equals 6. I have seen things like this. So what's the point of this? Well, if this is true, I'm going to say B is equal to 6. And if this is false, I'm going to say B is equal to 6. So why is this even in here? I mean, this really should just be if x is greater than 5, A is equal to 10. And then once you've left the if statement, then you always just say B is equal to 6. Okay? So these things can show up. Now, what we're going to see here pretty soon is that things aren't as simple as this, where we could just create a truth table. Like this, like I said before, this or the first problem. I could create a truth table that represented the entire statement and go through and see that they're equivalent. Pretty soon we'll find out that truth tables have a scalability problem. Okay, where it just becomes too cumbersome to try to work out all the combinations right out. It's easier to use a chain of rules like De Morgan's here and do replacements and eventually come to some conclusion.